Welcome to our CE marking series. This is the fourth module, how to review a technical file. So far we have learned that the technical file is important because enforcement officers are focusing upon technical files. We've learned how to select the right directives and the right regulations by using the matrix. And we have also learned our way through the confusion of different requirements from a variety of directives and regulations, including whether or not we need a technical file, whether we need an authorized representative, what they should be called, where they should be placed, and how to minimize our risks under CE marking requirements. What's it all got to do with me? Well, you need to understand how to review a technical file for a couple of reasons. One is you need to check yours is right. And if you have subcontractors, partners and suppliers, you need to make sure that theirs is right. You don't get points for pointing the finger at someone else and saying, well, we made a mistake, but it was their fault. If you ship the product, you carry the responsibility. So let's start with the age-old question, why do we have to go about this? If your company is going to be there for the long term, then you need to make sure that you have the necessary plans and CE marking compliant processes. You need to understand the issues, potential solutions and options. That's why we will explain why, how and what in this module. Remember that 90% of people supplying products into the EU are confused by the inconsistent and conflicting requirements and are probably going to get it wrong anyway. Bullshit, I hear many people say. We've got quality in place, but we spend a fortune on compliance testing, and putting these technical files takes a long time. It takes us far more time than we thought. Well, documenting regulatory compliance, whether it's UL, CSA or CE marking, isn't rocket science. It is just basic quality management, attention to detail, understanding the requirements and auditing the process. If the requirements or the processes are wrong, then you will have problems and it will take a long time to complete. But a quality management system guarantees compliance. Let's just look at this a different way. If you selected the wrong destination, it doesn't matter how well you follow the directions, you will arrive at the wrong place. If you have a GPS and you set the wrong destination, you'll get to the wrong place, particularly if you're in a strange town and you don't know the layout. You won't know that you're on the wrong track. You won't know you're on the wrong route until you finally realize, horror of horrors, that you may have driven 40 miles in the wrong direction. Corporate process and quality systems are exactly the same. If you give them the wrong information, they would take you precisely where you programmed them to take you. An accredited quality management system will merely verify compliance with a quality plan. If the quality plan is wrong, then guess what? You arrive at the wrong destination. Maybe the question we should ask is, does our quality plan include design verification and ongoing production verification as it's required by CE marking? About time now someone will ask, is this semantics or is it a real problem? The answer is yes. During the last 30 years we found a significant number of companies with ISO or similar accreditations that have had a serious disconnect between their quality, their design verification, and their production verification systems. The original quality plan was put in place to meet a particular accreditation. During the following years, it was tweaked, changed very slightly. But nobody asked the question, will it be able to maintain and demonstrate ongoing verification? My first answer of yes illustrates two supplementary problems. We're accustomed to asking leading and vague questions, and we seldom reflect our understanding. Watch for future blogs. Okay, I'll go along with it, but prove it. Well, here is a report published by the EU. It's recently been published and it's for the year 2010. It may be that 2,200 non-compliances may seem small to some. To the companies affected, it will have been a big deal. Some of them will have been bankrupted as a result of the actions taken against them. And oh, look at that. The number seems to be increasing. I wonder why that is. Do you think it's going to increase or decrease over the next few years? The picture is not rosy. The numbers are increasing. So how is that caused? Is it by the sheer number of increasing products on the market? Or is it that the designs are becoming worse and there is an increasingly defective proportion of products on the market? Were the designs compliant and they have become defective for some reason during their manufacture? Or is it just increasing market surveillance? Well, the answer is probably a little bit of all of those, but if we break it down into perhaps two solutions, training and support to improve the ability of our designers to design safe and compliant products. And the second area, to improve and integrate our data files, our technical files, into our company quality plans and quality management systems. Including in that is reviewing the files with your authorized representative. Remember that your authorized representative has a vested interest to making sure that your products are compliant. If he signs a declaration of conformity on a product which is not compliant, he stands a chance of being charged with trying to deceive an enforcement officer. The penalty for deceiving an enforcement officer is imprisonment. So your authorized representative is perhaps your best solution in the file design review to keep your company producing compliant products in a way that will maintain compliance during production. After all, if you fail, he goes to prison. Your authorized representative could be your best solution to ongoing compliance. To ensure ongoing compliance, here are a few questions to ask. Is there a post-design function managing critical and other component changes? If there isn't, then how does manufacturing and future manufacturing changes, component replacements, component obsolescence, how are these things going to be mapped back into the original compliance work which you did in design? Does the post-design function have a budget for compliance testing? Well, you needed to carry out substantial verification against a raft of standards. It therefore is logical that there will be component changes which will require retesting and recertification to ensure that the product is still compliant with those changes. Can they authorize verification testing, or must they seek permission from a higher authority? These two questions go together because they will determine if your company is truly focused on safety and compliance, or whether it is merely paying lip service to regulatory compliance. Remember that a mistake is evidence that someone has done something, whereas a compliant product is evidence that a team of people have done something successfully. Well, perhaps something is wrong. Creating a technical file shouldn't be any extra work. When you create the technical file, all you really are doing is taking existing information and putting it in one place. If you don't know what existing information you need, or you don't know where it is, then these are problems. But if you're really doing more than putting the information in one place, then something is wrong. So let's start by checking what should be there. Our plan of attack will be to identify what the majority of directives require in their technical file, and to produce a generic version which we can provide as templates for future products. This will work towards providing a competitive advantage for your company in its ability to create, maintain, and preserve compliance into the future, no matter what components change and what design changes occur in your product. The competitive advantage you will gain is by reducing or eliminating your cost of compliance, where cost of compliance includes the cost of recalls, the cost of litigation, which your competitors who do not have those processes in place will be paying. You won't be paying that because you'll do it right, therefore you will have a competitive advantage. This is a list of the requirements, the required topics by the Low Voltage Directive and a few other of the directives. They don't include everything, which we have on the next slide in our extended content. Here we have broken down some of those requirements into subsets, and we've reordered the content so that the larger, bulkier items like the manufacturing drawings are towards the end of the document. That means you can flick through the front end, which will deal with the design and compliance, where leaving the detailed larger items such as the archive of all superseded documents at the back, and preserve the data file from exploding in people's hands, which does happen. The extended content list includes flowcharts as required by the TOI directives. It includes a declaration of conformity, which isn't always specified in all of the directives. None of the directives directly address configuration management. Some, but not all, require, in general terms, the manufacturer to take whatever steps are necessary to ensure ongoing compliance. To most of us, that means configuration management. So to summarize, configuration management systems are imperative, particularly if there is a recall. If you don't have a CMS system, how do you know from what point the defect came into place, and therefore how many of your products do you need to recall? If you cannot identify to a high degree of confidence what needs to be recalled, then there is a high risk that you may be required to recall every product. and that will be vastly more expensive than putting a configuration management system in with all the necessary techniques and processes to ensure ongoing compliance. We will come to those later. A description of the product. What we call it, how we describe it. The purpose of this is so that the enforcement officer can identify it as yours, as the as-built standard which you've described in the technical file. Remember that people will take products, modify them, change them, repair them. You need to be able to demonstrate that the product which was defective, picked up by the enforcement officer, was a competitor's product, which the enforcement officer wrongly identified, a repaired or a modified product over which you had no control, and therefore the non-compliance was not your fault because you have documented how you put compliance in place and the risks. Alternatively, that the product was a counterfeit. If you have counterfeiting measures, this would be a good place at least to mention them so that the enforcement officer and your authorized representative can be aware of those issues and appropriately direct the enforcement officer away from your company. Next comes the declaration of conformity. This is just a general statement which will tell the enforcement officer what you've done and what to check. Make sure it is signed, truly signed with a real signature. This is a legal document. Your authorized representative and your company representative are signing in law that the product complies with mandated requirements. There are serious penalties for perjury and false declaration, and that's why this legal document must be signed. A list of directives applied. Now, the Declaration of Conformity will include this list, but the reason we're doing it as an additional section is so that you can include the matrix and your justifications and your rationale and your strategy for the directives you're using and those that you're not using. Similarly, the next section, list of regulations applied, will include your comments and your rationale, your written justification for using or not using certain regulations. Next, the standards applied in full. These must be harmonized standard. Quoting a UL, CSA or any other non-harmonized standards really has no value in a declaration of conformity, or does it have in the technical file. There will also be standards which you may apply in part. If, for instance, you have an industrial controller which may be under the machinery directive, which has an RS-232 output, which in part would be connected to an IT product and need to be reviewed or assessed to the IT standard 950. Next we come to the conceptual design. This would be an overview of the assembly, outline drawings to show what the product is, what's in it, how it works, or the functionality of different sections, how the product is going to be broken down. Descriptions and explanations. This is specifically for products which have either multiple or alternative or operating procedures, or for complex products may be driven by software, or for large installations. description of regulatory issues, solutions, hazardous boundaries, etc. This is the first part of identifying your product safety and EMC strategies, for instance, where the access areas are for operator or for skilled repairman. The requirements for those are different. Here you will clearly identify where there is hazardous primary voltage, hazardous secondary voltage, currents, energies, telephone network voltage, safety extra low voltage energy limited. You would include your philosophy and strategies for insulation and grounding. During the design, you will have made calculations on power budgets, thermal analysis, centre of gravity, and other issues. This is where that information goes, where it relates to compliance, specifically for safety. Copies of all warnings. Similarly for instructions. We now start into the compliance demonstration part of the technical file. This is a summary list of test reports, making sure that graphics are legible, that text is legible. Putting 4 sheets to a page is not good news for anyone. This will be your configuration record sheet listing the issues, dates of all of the reports which are contained in this section. The next separator will be for the REACH report, simply because this is going to affect everything. Keep copies for configuration management. The Roche report will also be included for most products, mandated for most products. Similarly, product safety reports, whether that's the general directive on product safety or whether it will be one or more specific product safety standards. Remember that in the EU the operating voltage is 230 volts and the frequency is 50 Hz. Specifying a rating as 230 volts, 50-60, 50 or 60 Hz, it will do, or 50-60, between 50 and 60 Hz will also do, although that means massive testing. Putting a rating label of 240 volts, 60 Hz will show you don't know what you're doing. That will be a red flag to an enforcement officer and he will dig deep. Next, we've put in an EMC report. That may not be necessary for all products, but make sure that the graphs are legible. Once again, 4 sheets to a page is not good news. Now we get to the configuration parts, the hardware parts. A list of the safety critical components is a big section. The next section is even bigger. The manufacturing drawings. This will permit the enforcement officer, and directed and helped by your authorized representative, to verify if someone has made unapproved modifications which may have affected the compliance of the product. This should also be the section which helps identify counterfeits, or at least identifies features which counterfeit products may not have. Schemes for components and subassemblies. Changes of these layouts can affect electrical isolation, heating, EMC and safety, so knowing where they are is key. Once again, vital for configuration records. Circuit diagrams once again affect performance, electrical isolation, heating and EMC. Schemes for circuits. The circuit diagram will define the connection between hazardous and non-hazardous voltages and currents, just like it does on a UL CSA submission. Process control flowcharts and production tests. These are essential for the toy directives and an excellent addition to any other technical file. knowing how the product was made and tested are also essential for the Toys Directive and make an excellent configuration record for your product. Last in this section, an archive of superseded documents. The last section is for other relevant material. There will always be an afterthought, well, this is where we think it should go. Thank you for listening and taking the time to study this video. We hope that this is useful for you and for your company, and that you're taking full use of the presentation material and handouts. If you're hearing my voice, then you are a VIP member. And I want to give you advance warning that my fourth book, The Encyclopedia of Electrical Product Safety, will be published during 2012. There are more than 250 pages, including full colour illustrations, and as a VIP member you will have free access to advanced copies of that material on this website. So please watch out for details. Thank you. This is Greg Kervil, and I look forward to talking with you in the future. And receiving your emails, please. Thank you. Send them through Annabelle. Thank you very much indeed. Bye-bye. And I can't let this opportunity to mention that the last slide in this series was 42. For those of you who are Douglas Adams fan, you may remember the answer to life, the universe and the everything was 42. Well, I don't know if you know the little bit more of the cause of that. Remember when the ape man is pulling the Scrabble cards and comes up with what happens when you multiply 6 by 9? The answer was 42. Did you notice that in the original movie he had 13 fingers? He wasn't counting base 10, which would be how we count, which gives us 54. He was counting base 13, for which 32 base 10 equals 42 base 13.